second. And there we go. Okay, and I'm going to move this off to the side as much as possible. And so here we go. All right, so tonight the good news for you is that it's a pretty short lesson. So now that's not true for what to do on Friday, but it is true for tonight. So tonight we are going to work on section 6.R.1, and so that is a section that's going to go into the developmental portion of your grade, and it's going to get you ready for section 6.1 that's due on Friday, that you are going to that's a little bit longer, and it's in the college algebra portion of your grade. So all of the instructions on every single homework or every single question in the homework that you'll have today say this. They say find the restricted value, and then they put an S right here in parentheses because you can have more than one, okay, not always. So they're not promising you that it's always plural, but you can have one, you can have none, you can have more than one. And so we're going to look at all of those kinds of things. So when you think about this, since you're in law enforcement, I think, if I'm remembering right, think restricted means things that can't happen. So I always tell my students, like, if you're 20, you are restricted from buying alcohol, or if you are 47 inches tall, you are restricted from riding a roller coaster that requires you to be 4 feet, or something like that. So these are things that can't happen. And when I show you an example, you'll see why they can't happen. So the first one I'm going to do is just to give you a pretty simple equation. They'll get a little bit more complex, but we never start off with the killers. So this is just a fraction. So f of x is going to equal negative 11 over 12x. And so when they ask you for the restricted values, what they want to know is what will make this not have an answer. And so if you think about this for a second, if I were to plug in 1, for the fun of it, I would have negative 11 over 12 times 1. I would actually be able to get an answer, negative 11 twelfths. I may not like the answer because it's a fraction, but that's an answer. And I could plug in 2 and I would get another answer, negative 11 over 24. And I could plug in 3 and I could plug in all these kinds of numbers. But what they want to know is, what can you not plug in? Basically, what can you try to plug in that's going to cause this to go haywire? And the way that you're always going to do that is you're going to say the denominator, which in this case is 12x, cannot equal 0. And so since these are like notes for everybody in class, I'm just going to write this. The denominator, oh, and I can't spell. I missed an N. I'm sorry. There we go. So denominator cannot equal 0. Now, the reason for that is if you try to divide by 0, your calculator gives you an error. Division by 0 is not defined. So the top or the numerator could be 0. We don't care about that, but the denominator can't be. So in this particular problem, just what we said, that means that 12x cannot equal 0. And then what you have to do is take that equation and solve it, basically get x by itself. So since I have a 12 right there, what I'm going to do is get rid of that 12. So I'm going to come in here and I'm going to divide this side by 12, and I'm also going to divide that side by 12. And when I do that, those 12s cancel and they give me x cannot equal, well, 0 divided by 12 is 0. And so this is my restriction. Basically, I can plug in anything I want to as long as it isn't 0. And so when you plug in your answers in Hawks, they are going to look like this. They're going to say x cannot equal, and then they're going to have a big box right here for you to plug in what x cannot equal. And so on a problem like this, all you would do is plug in 0 right there. So let me stop there for a second. Now, don't get too excited because they're not all that easy. Okay. But what do you think?
Makes sense.
Okay. All right. Well, let's try some more and let's make sure that all of them make sense. Because like I said, that one wasn't, We never start out with the killer ones. I was teaching my pre-cal class today and I was doing something and somebody's like, okay, it makes too much sense. Where's the, when's the bombshell coming? All right, so let's try this one. So I'll just call this problem number 2. I'm just going to keep calling these f of x. If Hawks happens to change that and calls it a g of x or something, don't be alarmed by that. That's just a naming. So this one's going to be 4x squared over 9x minus 9. And once again, the instructions on all of these, every single one of them are the same. So they're going to say, find the restricted values. And so remember, for a restricted value, what you are concerned with is the denominator. That numerator up there, the top, could be a smiley face, and you don't really care. So we're worried about the denominator. So in this case, we're going to say 9x minus 9. And you always say it cannot equal 0. And the reason, again, is because you can't divide by 0. You can divide by anything else, so that's why we say that it can. That's why we don't say that it can't equal anything else. It just cannot equal 0. And then what you do is solve this. So if I've got that minus 9, the first thing I'm going to have to do is get rid of that. And the way I'm going to do that is just by adding 9 to both sides. So when I do that, those cancel. And that gives me 9x. And remember, we've got this cannot equal. And I know that's a little weird because we're used to putting equal signs in there, but we've got this cannot equal. And then 0 plus 9 is 9. And then we're almost done. The only other thing I've got to do is get rid of that. So since it's 9 times x, I'm going to divide by 9. And then that's going to cancel out and give me x cannot equal 1. And so basically, my restricted value, I can have x be anything it wants to be as long as x is not equal to 1. And once again, the reason is, I'm going to do this just one more time. If I were to plug in 1 over here for my x, I would get 4 times 1 squared over 9 times 1 minus 9. And what that would give me is 4 over 0. And I'm going to put a big X right there because we are not ever allowed to divide by 0. So that's the problem. So basically, X can't equal 1 because that causes a 0 in the denominator. What do you think about that one?
Still good so far.
Still good so far? Okay. Then let me throw one trick at you before we do some harder ones. Okay. This one is a trick simply because it doesn't fit the pattern of the first two. And then we'll get to some that are a little bit more difficult. So we will go ahead and call this problem number 3. So I'm going to say in this case, f of x is going to be x minus 4 over 2. Okay. So the reason this one doesn't fit the pattern of the other one is you still have a fraction, so you still have a denominator, but you'll notice that you don't have any variable in the denominator. All you have is just this number. And so if we did this like we did the other ones, what we would do is we'd come over here and we'd say, okay, my denominator 2 cannot equal 0. Well, then on the other ones, we solved for x, but the problem is you don't really have an x to solve for. And that equation right there that we're looking at is true. So 2 does not equal 0. And so when you get something like this, where you have no variable in the denominator, and so I'm going to write that down. Basically, you have no variable or no x, however you would like to word that, in the denominator. And I'm going to abbreviate that. What that means is that there are no restrictions. Pretty much x can be whatever it wants to be. And the reason is because every single time, no matter what I plug in for x, I'm going to be dividing by 2. I'm never going to be dividing by 0 because that 2 in the bottom is just a number. It doesn't change. And so since I can't ever divide by 0, that means that I have no restrictions right there. So if you have a problem like this, what Hawks will look like on your answer choice is it'll have this x cannot equal a box, and then it'll have like right beside it a little button that you can pick that says no restrictions. And so if you have one that has no restrictions, you just wouldn't put anything in that box right there. You would just click the little no restriction tab. Still good?
Still good. Yeah.
Still good. Okay. All right, then let's get to the harder ones.
Great.
All right, so the harder ones are essentially ones where it's a little harder to solve for X. So the thing that doesn't change is this instructions, but since these are going to take a little more space to solve for X, I'm just going to erase this whole thing right here. Just know that our instructions are still find the restrictions. So this time we're going to let f of X equal, let's see, we'll do X plus 1 on the top, and then on the bottom we're going to do, oh, I don't want a parenthesis there because I don't think Hawks puts them. So we're going to do X squared minus 4X plus 3. Okay, so it's still a fraction, which means that we still have a numerator and the denominator. And if we're going to find the restricted values, what that means is that you are always going to take that denominator, whatever it happens to be, and say it cannot equal 0. Now, there are 2 ways that we really could do this. And since you're the only one in here, I'm going to ask, and if you prefer one way over the other, then we'll do them your way. But if you want to see both ways, then we can do one way and one the other. But this is a quadratic equation. And the reason that we know it's quadratic is because it's got an X squared. And so when we are solving a quadratic equation, we can really do 2 things. You can factor it. If it factors, I'm not promising you that everything does, but in this section, I'm pretty sure they all factor. Or you can do the quadratic formula. Do you have a preference?
Factor.
Factor. Okay. All right. So if we're going to factor, let's go in and let's remind ourselves of a couple of things. So if we're going to factor, remember this last number right here, we need 2 numbers that multiply to be this number. So in our problem right here, we're going to need to think of 2 numbers that multiply to be a positive 3 and that add to be a negative 4. So off the top of my head, the only 2 things I can think of that multiply to be a 3 are I'm going to put it over here.
Negative 1 and 3.
There you go. And you are exactly right. Both would have to be negative. And the reason both would have to be negative is because a negative 3 times a negative 1 does give me that positive 3. But then a negative 3 plus a negative 1 gives me that negative 4. So the way that we're going to factor this is we're going to say, okay, X minus 3, since we got that negative 3, X minus 1. And then remember, we still have that cannot equal 0. There you go. And then remember, when you're factoring a quadratic, you've got to go another step. Once you have it factored, you take each one of these factors, and normally you say they can, you set them equal to 0. But in this case, we're saying it cannot equal 0. So X minus 3 cannot be 0. X minus 1 cannot be 0. And then what we're going to do is take each one of those and solve them individually. So X minus 3 can't be 0. So that means we're going to add our 3 right there. And that's going to say X cannot be 3. And then X minus 1 can't be 0. So we're going to add our 1 here. And that's going to say X cannot be 1. So this is the first problem that we have done where you actually have 2 numbers that you have to restrict. And so when you plug them into Hawks, remember it's going to have X cannot equal and that box right there. So what you'll have to do is plug both of them in and just make sure that you put a comma in between them. Otherwise, it might think that I meant 31. So just make sure you put a comma, and the order doesn't matter. So you could put, if this was a problem on Hawks, you could put 3,1, or you could put 1,3. It doesn't matter. But make sure you don't do this. This is a real common thing that I get from a lot of my students. They'll come in here and they'll try to put them in parentheses. So
Okay.
make sure you don't do that, because this is not a point. It's not an X comma Y. It is just both X cannot equal. So don't put them in parentheses because that implies a point. All right, what do you think about that one?
So far, so good.
So far, so good. All right, let's try another one. Okay. I like so far, so good. You getting ready for the end of the semester?
Yes, very much so.
So is everybody else. I have 2 sons in college and they are just about tired. I'm having to get on them now because I'm like, go do your homework.
No.
All right. Sorry, I forgot to change my function. I erased everything else, forgot that. Okay, so let's try this one. And here's the good news. This is actually, in my opinion, the most difficult one. So unless you don't have any questions, this is probably going to be one of the last ones that we do, but we are going to make some references to what you're going to do for Friday, just since, you know, I want you to make sure that you can connect these two things. So here we go. F of X is X squared plus X plus 8. And then over 8x squared minus 5x. And once again, you still want to find your restricted values. So a lot of times people get real antsy on this one and they think that this one maybe doesn't fit the rule because it's got a quadratic in the top and a quadratic in the bottom. Once again, for the restricted values, we don't care what's in the top. It doesn't matter. So all we're going to do is we're going to take that denominator, 8x squared minus 5x, and we are going to say it cannot equal 0. Always. Doesn't matter what the numerator is, just take the denominator and say it can't equal 0. But now, one of the reasons that I picked this one is because most students are like you and they prefer to factor. Believe me, I would rather factor than do the quadratic formula too. But then when they get to something like this, they forget how to factor it because you're pretty good at factoring those 3-term things like we did last problem, but they forget how to do this one. So this is just 2 terms. And so you can't quite factor it the same way. So what you want to do is you want to treat these terms kind of separately for a second. So I'm going to kind of underline them. This is 1 term and that's 1 term. So you want to do what's called the greatest common factor. You want to essentially take out what they have in common. So you want to look at 8x squared and negative 5x and say, okay, what do they have in common? So what do you think? What do both of them have?
Variables.
They do, and it's an x, right?
Yes.
So what we're going to do is we're going to factor an x out of the whole thing. So I'm going to pull that x out and I'm going to put parentheses right here. I'm going to go back to red because it shows up a little better. And then what you want to do is you want to remember that factoring is really dividing. So if you had an 8x squared and you already took out an x, what that leaves you with is just 8x. And then we have the minus. And if you started out with 5, took out the x, you've got a 5 right there. And then I'm going to remind you cannot equal 0. And then what I'm going to tell you, and I'm going to kind of do this in a different color because I'm going to do it a little far off because I'm going to erase it in a second. If you ever get one of these and you're unsure, you know, like, did I factor it correctly? Did I not? Not real sure. What you can do is just really quickly redistribute that. And so if you take x and multiply it by 8x, you'll get 8x squared. And then if you take x and you multiply it by negative 5, you will get negative 5x. And that's what you started with. So that should tell you that, hey, yeah, I really did factor that correctly. And so once you've got it factored, then the good news is it's exactly like the last one. You just take both of those factors and set it not equal to 0. So in this case, we're going to say the first factor, x, cannot equal 0. Or we're going to say the second factor, which is 8x minus 5, cannot equal 0. And then the good news is that one's already got x by itself. It's solved. That's kind of nice. We love things like that. This one, on the other hand, not so much. All right, so we've got to add 5 to both sides. So that tells me 8x cannot equal 5. And then we have to come in and divide by 8. And I'm running out of room, so I'm going to write it over here. So that tells me x cannot equal 5/8. So this is another one where you have two numbers that you must restrict. And so the way that you input that is make sure that you just put both of them in that box, but you put a comma in between them. And remember, the order doesn't matter. So another thing too, just kind of as a note, when you have two numbers, what that generally means is that you started out with a quadratic in the denominator. On those first questions that we did today, we only had one number that we had to restrict. It was because we just had a linear equation, just a plain x in the denominator. And so we didn't have to restrict a bunch of numbers. And then it is possible to have a question that is greater than an x squared in the denominator, but at this level of math, you won't see that. So everything that you deal with on your homework will be at most an x squared in that denominator, nothing else. All right, so let's stop right there. What do you think?
I think I'm still good.
Okay, all right. Well, so here's the good news. All right, that right there is absolutely everything that you're going to see in this particular section. Okay, so that right there will get you through the homework that is due, what is today, Monday? It's due tomorrow. Okay, so every single one of them looks exactly like that. I did 5, I think there's 7. Okay, so I may be wrong. Yeah, nope, I think there's 7. Okay, so you'll have a couple more. You probably have 3 quadratics maybe instead of 2, but they look the same. But now just as a note, okay, on section 6.1 that's coming up on Friday, you are going to have to do a couple of things. So when you're preparing for that, I want you to think about something. They will talk to you about something that is called a vertical asymptote. And they never really call it anything else. They just call it a vertical asymptote. And so most students don't make the connection. A vertical asymptote is the same thing as a restricted value. Now we're going to graph with vertical asymptotes, so you will have to know, and we'll talk about that on Thursday. You will have to know how to graph them and stuff like that. But if you can find a restricted value on all of these other problems, basically just set your denominator and say it cannot equal 0, then you can find a vertical asymptote because they are the exact same thing. And I'm not really sure why Hawks doesn't make that connection very well. But they tend not to. So I always remind students of that. That way, you know that, hey, when they start talking about vertical asymptote, it's not this whole new thing that you've never even heard of before. It's just finding a restricted value. So just take your denominator, set it not equal to 0, and go from there. All right. You have any other questions or anything else that I can help you out with?
No, ma'am, I don't think so.
Okay. All right. Well, then I don't think you'll have much trouble knocking this homework out. And then, like I said, make sure you get this stuff down, because then we're going to kind of build on top of it. And we're going to talk about all kinds of asymptotes and stuff for what's due on Friday. And then that is actually your last homework section. So the one that's due on Friday, then you have a mini test, and then it's the review. So be watching Canvas. We were going to put up some announcements on Friday, actually, talking about your final exam and the date you have to have it taken by, and all that kind of stuff. But we're trying to wait till everybody gets some of their last homework done so that we don't confuse everybody with those announcements. All righty.
Okay. Yes, ma'am.
All right. Well, you have a good evening, Shane. All right.
Thank you. You too.
All right. Bye-bye.